Now for the star of the show. Generative AI is what put AI on every executive's roadmap, and it's the single workload reshaping data centers right now. Let's see how it actually works under the hood, where it shines, where it stumbles, and the all-important difference between the big and small language models you'll be asked to support. So what actually is generative AI? The slide breaks it into 5 ideas that build on each other. Let's walk them. Number 1, top left. These are models that create brand new content. Not sorting existing data, generating it. Text, code, images, audio, all of it. Number 2, how do they pull that off? They learn the deep patterns in a massive pile of training data, then generate novel output that follows those patterns, something that never existed before. Number 3, they're built on large neural networks, and that word in the middle, transformers, is the architecture behind almost every model you've heard of. Tuck that term away, it comes back all course long. Number 4, top right, you'll see GANs on the exam, generative adversarial networks. Look at the little diagram. A generator makes fakes, a discriminator tries to catch them, and they compete round after round until the output looks genuinely real, two networks pushing each other to get better. That's the adversarial part. But number 5 is the one that pays your salary. Look at it. Training is massive and offline. Thousands of GPUs. Days to weeks of compute, all to build the model once. Serving it, inference, online, is interactive. A user types a prompt and expects a fast, low latency answer. 2 completely different infrastructure problems from the same model. Training is a marathon you run once. Inference is a sprint you run 1,000,000 times a day. And that strip across the bottom is the whole life cycle in one line. Data sources pre-process and tokenize, train the large model, deploy and serve. User interaction. Every stage lands on your gear. Storage for the data, GPU clusters, and a lossless fabric for training. Low latency infrastructure for serving. That combination, enormously expensive to train, latency sensitive to serve, is exactly what's driving the GPU gold rush, and it's why your fabric and storage design suddenly matters so much. Keep that 5-step picture handy. It frames the entire course. Okay, let's dive in, and the whole story of this slide reads left to right, so let's follow it. Start on the left, under Gen AI use cases. This is where generative AI actually earns its paycheck. You've got virtual assistants answering questions and automating busy work. Code generation, writing, completing, and explaining code, so your developers move faster. Content creation, blogs, emails, marketing copy at scale, summarization, taking mountains of documents and boiling them down in seconds. And at the bottom, RAG, retrieval augmented generation. Pay close attention to this one because it's everywhere now. RAG means the model pulls in your company's data before it answers. So you get accurate, context-aware responses instead of generic guesses. Now look at the center, that brain on the pedestal. That's the model itself, and here's what people forget. Training it is hard, but serving it every single time a user hits enter is its own beast. That's inference, and it's what the right side of the slide is warning you about. Swing over to those inference challenges. Number 1, see the speedometer? Inference has to be fast. Your users won't wait. A slow assistant is a dead assistant. 2, look at that GPU. Bigger models give better answers, but they need a ton of GPU memory just to load and run. 3, the sneaky one, the model generates output 1 token at a time, and each token depends on the one before it. It's a chain. You can't skip ahead, so you're fighting latency and throughput on every request. Think of it like a single-lane toll booth at rush hour. Every car waits its turn, and the line backs up fast. And 4 ties it together. All of this drives hard demand for high bandwidth, low latency infrastructure. That bottom band, fast responses, GPU efficiency, scale, reliability, that's the payoff when your gear keeps up. Here's the deal. The one thing to carry out of this slide. Every shiny Gen AI feature your boss asks for on the left turns into a concrete hardware demand on the right. Use case to infrastructure. That connection is exactly what the rest of this course builds. Keep it in your back pocket. The exam loves it too. Generative AI is powerful, but it is not magic, and the exam wants you to know its limits. The slide gives us 5, so let's go around. Number 1, hallucinations. The model can be confidently completely wrong. Look at that example. The Great Wall of China is visible from space. Stamped 100% confident. That's a famous myth, and it's flatly false, but the model says it with total swagger. That right there is the danger. Fluent, convincing, and wrong. It's also the number one reason we ground models with our own data through RAG. Number 2, bias and fairness. A model learns from historical data, and if that data carries bias, the model carries it right back out. Historical data in, biased outcomes out. Number 3, the footprint. Training and running large models takes massive compute and energy, and that drives real cost and sustainability concerns. A rack of GPUs isn't just expensive to buy. It's expensive to power and cool. Now, number 4 is where you, the infrastructure pro, get to be the hero. Resource optimization. Look at the techniques. Quantization to shrink the model, using smaller purpose-built models instead of one giant one, and caching results so you're not recomputing the same answer twice. And see the payoff tags: lower latency, lower cost, lower energy. Smarter, not just bigger. That discipline is what separates a pro from someone who just throws GPUs at the problem. And wrapping all of it, number 5, governance and guardrails are part of the design, not an afterthought. Define policies, monitor and detect issues, add safety controls, audit, and keep improving across the whole AI lifecycle. Here's the mindset to carry out. As the person running the infrastructure, you're not just keeping the lights on, you're enabling responsible, efficient, trustworthy AI. That same Watson guardrails thinking comes roaring back when we hit sustainability later in this module. Powerful tool, real limits, designed for both.